Hello everyone, today we will talk about the phospholipids. In previous lecture we have talked about the definition of lipids, their classification, and we have also discussed the simple lipids. Before moving ahead with phospholipids, let's first talk basic about the lipids. So lipids are organic compounds which are largely insoluble in water and soluble in organic solvents, and they are classified as simple lipids, compound lipids, and derived lipids. Simple lipids contain fatty acid and alcohol. Compound lipids contain fatty acid, alcohol, and additional groups. Derived lipids are hydrolysis product of simple and compound lipids. In previous lectures, we have discussed about the simple lipids, that is triacylglycerol and waxes. In this lecture, we will discuss about one of the compound lipids, and that is phospholipids. Rest of the lipid we will discuss in other section. So let's talk about the phospholipids. Phospholipids contain fatty acid, alcohol, and phosphate group. They are amphipathic in nature, means they have two parts. One can interact with water, that is hydrophilic, and one hate water, that cannot interact with water, and we call it hydrophobic. They are major lipids present in plasma membrane. So we always use the term phospholipid bilayer. Plasma membrane is made up of phospholipids. Major lipids present on plasma membrane are phospholipids. Phospholipids are further classified on the basis of their backbone alcohol. So they are glycerophospholipids, and they are also called as phosphoglyceride and sphingospholipids. Glycerophospholipids had backbone alcohol present here is glycerol. Glycerol is 3 carbon containing alcohol, and each of these carbon are attached with hydroxyl group. And hydroxyl group present on first and second number carbon interact with fatty acid, and hydroxyl group present on third number carbon interact with phosphate, and this phosphate again interact with another group, and here it's represented with X, where X can be a hydrogen or alcohol. Here in case of sphingospholipids, backbone alcohol present is sphingosine. Sphingosine is 18 carbon containing alcohol, and it has 2 hydroxyl group. One is present at first number carbon and one is present at third number carbon, and on second number carbon amine group is present, and fatty acid interact here with amine group. Here in case of a glycerophospholipid, fatty acid interact with hydroxyl group, whereas in case of a sphingospholipids, this fatty acid interact with amine group, and this hydroxyl group present on first number carbon interact with this phosphate, and this phosphate interact with this X group. In case of a sphingophospholipid, this X represent an alcohol. So let's first talk about the glycerophospholipids. So here backbone alcohol is glycerol, and first and second hydroxyl group present on first and second number carbon interact with fatty acid. So different kind of fatty acid can be present here. We have already discussed about the different types of fatty acid in previous lecture. You can follow that, or let's discuss some basics about the fatty acid. So fatty acid is made up of long hydrocarbon chain, and this which is a non-polar, and this is polar group, that is carboxylic acid. Fatty acid can be of different chain length. Means they are made up of different number of carbon, like 14 number carbon, 16, 18, 20, 24, and they are different on the basis of degree of saturation as well. So they, on the basis of that, they are classified as saturated and unsaturated fatty acid. In saturated fatty acid, all the carbon are engaged with hydrogen, engaged in bonding with hydrogen, and unsaturated fatty acid has double here the carbon are attached with double bond, and they are called unsaturated because all the carbon are not saturated. Unsaturated fatty acid are further classified as monounsaturated if single double bond is present, and they can be polyunsaturated with many double bonds are present. So here fatty acid will interact here, this OH from here and H from here will released as water, and this will now attached here. So here is the final glycerophospholipid molecule. So this is the fatty acid chain attached here with ester linkage at first and second position here, and with this alcohol present on third number carbon will interact with phosphate, and this phosphate will interact with this X group, where X can be hydrogen or alcohol and R are to represent the hydrocarbon chain. And this is the final glycerophospholipid molecule. So here the glycerol act as backbone, where phosphate and alcohol are attached here on this third number carbon, and fatty acid are attached here on first and second number carbon. So they align themselves in opposite direction. To hydrophilic part is here, and in opposite hydrophobic part is present here. So we always show phospholipid bilayer like this. Hydrophilic head is here and hydrophobic tail is here, which represent the fatty acid. So let's see what different kind of X are present here. Simplest glycerophospholipid have hydrogen present as X, and this glycerophospholipid is called as phosphatidic acid, and it is also named as diacylglycerol 3-phosphate. Diacylglycerol because this is the diacyl, 2 acyl group present here, and this is glycerol molecule, and on third position this phosphate group is present. So this is called as phosphatidic acid or diacylglycerol 3-phosphate. And net charge present at pH 7 on this group is because of phosphate group, that is -1, because other groups are uncharged. Next example is here. In first case hydrogen was present here as X. In another case, another glycerophospholipid, here X will be alcohol. So here the amino alcohol is ethanolamine, and the final glycerophospholipid form here is phosphatidylethanolamine, and this is also called as cephalin. Net charge on this phosphatidyl ethanolamine, phosphatidylethanolamine is 0, because ethanolamine has this positive charge, and here phosphate group has negative charge. So positive and negative will neutralize each other, and finally this molecule will have 0 charge. Next alcohol present here as X will be choline. So choline also has 1 positive charge, and this glycerophospholipid is named as phosphatidylcholine, and it is also called as lecithin, and net charge on this is also 0, because 1 positive charge is present on this choline and negative charge present on this phosphate group. Next one is serine. Serine is an amino acid. So it's amino acid and its R group contain alcohol, and this final glycerophospholipid is called phosphatidylserine, and net charge on this glycerophospholipid, that is phosphatidylserine, will be -1, because this amine group present here and carboxylate ion have positive and negative charge. They will neutralize each other. So final charge will be -1 because of this phosphate group present here. So all these were example of glycerophospholipids. Let's see another example. Another example is inositol. When inositol will present here as alcohol, this phospholipid is called as phosphatidylinositol, and net charge present on inositol is because of this phosphate group, because there is no charge present on this inositol. Next one is phosphatidylglycerol. Phosphatidylglycerol, when it will be present as X here, it is called diphosphatidylglycerol, because here this is one phosphatidyl molecule and here this is another phosphatidyl. So this is diphosphatidyl, and now extra glycerol is present here. So this molecule is called as diphosfatidylglycerol, and it is also called as cardiolipin. And net charge on this molecule phospholipid, this diphosphatidylglycerol, will be -2 because of these two phosphate. One negative charge present here and another negative charge present here. So this was all about the glycerophospholipids. Now let's talk about the sphingophospholipid. Here the alcohol present as backbone is sphingosine. Sphingosine is made up of palmitic acid and serine. They interact together to form sphingosine. This is sphingosine. Now, fatty acid chain, this carboxylic acid present in fatty acid chain interact with this amine group present on second position of this sphingosine, and this interact with amide linkage. In case of glycerophospholipid, this fatty acid was interacting with OH group, alcohol group, with the ester linkage, but here linkage is different. Amine group are interacting with carboxylic acid, and linkage here the bond formed is amide bond. And this molecule, when sphingosine interact with this fatty acid, this molecule is called ceramide. And when this ceramide interact with this phosphate and alcohol, they form sphingospholipids. So this is the representation of a sphingophospholipid. Here the only single fatty acid chain is present, which is hydrophobic part, and alcohol and phosphate are hydrophilic part. They have aligned themselves in opposite direction. They can be represented as this as well. Example of a sphingophospholipid is when alcohol present in this sphingophospholipid is choline. This is called as a sphingomyelin, and this sphingomyelin is very abundant lipid, phospholipid present in membrane of nerve tissues on myelin sheath. So this was all about sphingophospholipid and glycerophospholipids. Thanks for watching.